Okay, from this one we're being asked to find the second derivative of w, which is given to us as 5z to the second e to the z. So when I'm looking at this, I'm going to rethink of it as 5z times e to the z, and I'm going to use the product rule. So I'll start by finding the first derivative, which says keep the first and find the derivative of the second. And so the derivative of e to the z stays e to the z, plus the second, which is e to the z, times the first, and I see that I left off my 2 there, so let me write that in. So using the power rule, the 2 will multiply by the 5 to give me a 10z. So when I clean it up, I'll have 5z to the second e to the second plus 10z e to the second. So that is the first derivative. What we want to find is the second derivative. So we'll be taking the derivative of this. Now, one thing that hopefully you noticed is that when we took the derivative of w, we ended up with our first term being that original w. So I'm going to use that as I work this problem. So when I'm finding the derivative of this, I know that it's going to be this whole thing. So I'm going to put that in. Now you could work it out, but if you notice that, it does save you a little bit of time. Now I need to find the derivative of the second part. I'm going to use the product rule as I've grouped it in green. And so I'll put it here. Keep the first times the derivative of the second plus the second times the derivative of the first. And the derivative of 10z is simply 10. So I'm going to clean it up. So I'm just going to drop the parentheses around the first and I'm going to, like I said, just clean up this second part. And hopefully you noticed while you were writing it that we do have like terms right here that we can combine. The 10 plus 10 gives us 20 ze to the z. And that is exactly what we would put in to our answer blank as the second derivative.